Hello and welcome to another video concerning statistical analysis. We're going to be talking about the Anova. Anova stands for Analysis of Variance, and we're going to, of course, use Excel in order to show you how to interpret the data in regarding to this type of test. Um, you will see that there are three level of salaries for three different major: economics, medicine, and history. So once of these people graduated with these three types of degrees, these are the salary that have been observed about these recent graduate in medicine and history. We wanted to go ahead and do the ANOVA test. So there is a hypothesis, null hypothesis, which is usually it's addressed as the mean of the population of the three population rather is going to be equal. So mu1 and mu2 and mu3 are based on the null hypothesis are equal. What would be the alternative hypothesis? At least one of these three means is going to be different. That is what the ANOVA analysis is going to allow us to do. So we're going to be doing actually what we call a single factor or one-way ANOVA. So this is basically, that's what we're going to show you. So we're going to take a deep breath again, and we're going to perform the single factor ANOVA by doing the following. We're going to go to the data. We already installed data analysis. If you don't have it already available for you, you need to go to File, go to the option, and click on Add-ins, and go, and you will see it's going to be available for you. It's checked already because I have it already installed. So we have the data analysis, and I'm going to click on it. I'm going to look at where is the ANOVA single factor, which is the first one, and because it's alphabetical order, in alphabetical order. So I'm going to say here, OK. It's going to ask me for the input range, which is the three of those. It's very good idea to have the label of the columns included as well. And if you do this, make sure that the column is being checked for a group by. And also, since you did actually check, added the label, you need to check this little box. I'm going to leave the alpha at 0.05, which means we have a confidence level at 95%. And I'm going to specify the output for the data analysis result. It's going to be here in E1, close to it, and I'm going to go ahead and show you the result in one click of a mouse. Look, all this different data, and it's going to have a lot to generate for us to do actually our own interpretation about it. Quickly, you could see how easy it is to really look at the data. Because we included the label, it was named meaningfully. So we have economics, medicine, and history. The count, it did count. With ANOVA test, we don't have to have the count equal like regression later, where we have to have the same observation for every variable. And the sum, that gives us a very good idea. The average salary for a graduate in economics is 48,000.33, and the average medicine 60. Maybe that's not realistic, but at least that's what the observation is based on. I'm not going to really argue about that. And the history is 43,000. So medicine is the highest. That makes sense. Economics and history is the lowest in this case. The variance, which is the standard deviation, meaning uh, uh, that's actually the variation of the data from the mean. The variance, as we all know, it is the square value of the standard deviation. Remember, ANOVA is the analysis of variance. Uh, so what we wanted to do, we're going to either accept the null hypothesis or reject it. One more time, the null hypothesis is based on the fact that it's going to be all the three means are equal, or at least one of them is different, but we don't know which one of these is different than the other. If we're going to really focus on that need to know which one of these means is different from the other, of course, we're going to run t-test, which we're going to cover in a couple of videos down the road. But now we're going to decide how to, whether to accept it or reject it. First of all, it's going to take us 1 minute to do this, and that's the beauty of using Excel for those tests, so it doesn't have to take forever. I'm going to highlight the F value, and I'm going to make it here green, and I'm going to also highlight the F critical value, and I'm going to make it also, let's make it yellow so we could see here. It doesn't matter, I'm not really being consistent with the colors. Toward the end of the list of the videos, we will be consistent with the color for this type of testing. It's not going to be a big deal. But green versus yellow, and we're going to see who's going to win. If the value of F is greater than the F critical, we reject the null hypothesis. So obviously there is a lot more value in F than there is in F critical. Actually, I could go ahead and even do these three cells just to be a little bit neater. And I could say here equal if this value is greater than this value, we're going to say go ahead and reject it. Otherwise, reject it. Otherwise, accept the null hypothesis. And it's really very easy to see this. And now with an if statement, we see we have rejected that. If actually the rejection is green or red or whatever color you agree on it, and say let's say reject is red and accept is let's say blue, I could go ahead and do the conditional format. I could go to a new rule. I'll go to a format only cell that contains. If the cell value is equal to reject, you could go ahead and do the color that you like or whatever you agree with your team. If you're doing with the work with other people, and we could go ahead and do, let's say here green for reject, and I'll go ahead and format. You know, I could go ahead and select that. I should have done it all at once with managing rules instead of doing it individually. In next videos, I'll do that. So I'm going to go ahead and say format only cell that is, again, equal to, and in this case, we're going to say accept. You know, here we go. So, and if that is the case, we'll go ahead and make it, let's make it a little bit nicer color. So we could go ahead and do the yellow with these two colors. So we could go ahead and do that. Of course, we're not going to see the two colors unless this value, for whatever reason, I'm trying to force it to be 70. And in this case, it's going to change. But of course, that's not 70. So I'm going to go ahead and undo in order to bring it. It's a test to see if this cell is going to respond to the changes, if that change actually took place. Again, this is Anova. Anova, it's a single factor test. As you notice, we have three groups. We counted them. The data analysis counted them, given the sum, the average, the variance. Anova is going to check if the three means of the three groups are equal. And of course, in this case, we did find out that they are, at least one of them is not equal to the rest. So Anova is going to be, one more time, it's about the analysis of variance. So you find again, the means, three of them are equal. If you have four, you're going to have to set that in the null hypothesis, all the means are equal. The alternative hypothesis should be stating at least one of these means is different. Well, thank you very much for taking your time to watch this. Here's Dr. Sam Hijazi. I hope to see you in the next video. Thanks a lot.